So remember that if triangles are going to be similar, if polygons in general are going to be similar, the angles have to match up to be pairwise congruent and the sides need to be proportional. Okay, so on number 3, the first one, you do have vertical angles that are congruent. However, the sides are not proportional. You can either check 39 to 16 and then 40 to 16, or you can say here it's a 1-to-1 ratio and it's not a 1-to-1 ratio in the other triangle, so it's not they're not proportional. Okay. When I ask you for scale factor, whoops, sorry. When I ask you for scale factor, you go left to right unless it specifically says triangle, whatever to triangle, whatever. If it doesn't specify, then you go from the left to the right. So since the triangle is getting smaller, the numerator will be larger and it's 6 or 6 to 1. You can put, if you want to put 6 to 1 like that, that's okay. Or 6/1, that's okay. You don't have to have the 1 there because it's the denominator though. Okay, and then remember, all you have to have are angles for triangles to be similar. So on this one, even though you don't have any side lengths, and therefore you cannot give me the scale factor, you would know that they're similar triangles because you have the 2 pairs of congruent angles. So angle, angle makes them similar. And here is the bottom of that page. What do you need to see? So on number 4, I probably should have told you the similarity, how things matched up, because it's a little, like you really shouldn't have to assume, but the 11x plus 11 was supposed to match with the side that's 30, and the 77 was supposed to match with the side that's 21. So I really should have given you a similarity statement there so you would know how the sides should be matched up. Okay. Now, number 5, I realized that this is something we had not gotten to in lesson 2. 1. I'm not sure, whichever section it was. That is something we didn't get to, so we're going to talk about that today. But if 2 triangles have a scale factor, if 2 triangles have a scale factor of, for example, 2-to-1, sorry, this one's 1-to-2, the perimeters will have the same scale factor. It'll also be 1-to-2. So perimeters are in the same scale factor as the shapes are. Okay, so you don't have to actually find all the side lengths in order to answer what the perimeter is for 5B. Okay, if you know that the scale factor is the same as the perimeter ratio. Questions on first page, anything? Okay, the second page is going back to the determining proportionality by the definition, not with the shortcuts. So I guess for this one, well, no. Technically, you should be able to say that these are similar by angle, angle. I probably wouldn't have given you all that information because this is actually using the definition. Okay, but for quadrilaterals, you don't have those shortcuts like side angle side and all that. For quadrilaterals, you have to know all 4 angles are congruent and you have a pairwise congruent, and you have to know all the sides are proportional. for quadrilateral. So for this one, you have to check all four pairs of sides are proportional. How do you know on number 3, how do you know that if you do 14 over 10, that it should be x plus 9 over x plus 6? How do you know which side corresponds to 14 over here? Yeah, look at the angles, okay? So the 14 is between the single and the double rectangle. The x plus 9 is between the single and the double rectangle. Okay, the 10 is between the double and triple, and this one's between the double and the triple. So when you set up your proportion, 14 to 10 is x plus 9 to x plus 6. Or what's another way that you could write that proportion? Give me a different way to compare 14. 14 to what? 10 over x plus 6. Again, you know that they're equivalent proportions because when you cross multiply, you would get the same thing. You can either say this one compared to the corresponding side in the other shape, and then this one compared to the corresponding side in the other shape, or you can compare the two sides in the one shape and then the other, the same order in the other shape. Okay, but you got to make sure that you pay attention to how the sides correspond. Okay, and then over here, so the one across from the double marked angle is 6. So the one across from the double marked angle here is x minus 3, so they should correspond. And then the one across from the 40-degree angle is 12, and the one across the 40-degree angle is x plus 1, so these guys should correspond. So again, you can do 6 to 12, and then x minus 3 to x plus 1, or you could do 6 is to x minus 3 as what? 6 is to x minus 3 as, what would be the rest of it if you do it that way? If you, yeah, 12 over x plus 1. And again, 6 times x plus 1 equals 12 times x minus 3. So as long as you get the same cross product, that means that your proportion is equivalent to one that I've written. Okay, but be careful about how you match up the sides. So use the angle markings to figure out how the sides should be compared. Questions on 1 through 4? Again, scale factor will go from the left to the right if it does not specify which way to compare it. Why is the scale factor an improper value? Why on number 1 is the scale factor an improper number? Yeah, you went big to small, so that means that when you're doing the comparison, your fraction will be improper because the first one is larger than the second one. So it doesn't matter, since 5/3 is exactly 1.6 repeating, that's okay. Don't write 1.6, okay, no rounding. I'm perfectly happy if you leave it as a fraction, but just make sure you don't round. Okay, now on the next one here, you can figure out that the scale factor is 5 to 7 because the side lengths here that you actually are given are 15 and 21. Now, if you know that and again, this is something that we didn't talk about, we need to. If you know that the perimeter is the same as the perimeter ratio, is the same as the scale factor, you can just find the perimeter of this shape and then make a ratio, make a proportion to figure out what the other perimeter is. You don't have to actually find all those side lengths. Okay, so the scale factor is 5 to 7. So this perimeter compared to this perimeter is going to be in a 5 to 7 ratio. So here are two pools. Are rectangles always similar to each other? Are rectangles always similar? So in other words, do rectangles have to have the same size and shape? Sorry, do they have to have the same shape? They don't also have to have the same size. Do all rectangles have to have the same shape? Meaning like proportionally, are they the same? Well, here's a rectangle. And here's a rectangle. Are those going to be similar? If this is a square, what is the ratio of the sides? Actually, let me do this. What's the ratio of the sides over here? It's a square. Yeah, this would be like 1 to 1 to 1 to 1, right? If this is a rectangle that's not a square, let's say this is like 3 and that's 7. Is that going to be similar to this? No, because not all the sides are congruent. Rectangles don't have to all be similar because some rectangles are like long and skinny, some are squares, some are more, like squares. So in general, rectangles will not have to be similar. So they don't have to be the same shape because they could look more like squares or less like squares. Okay, so this one, they gave you the dimensions there. So when you compare the ratio of these two sides and then compare the ratio of these two sides, they both are a 4:7 ratio. Now again, you could also do 84 to 70 and compare that to 48 over 16. 48 over 40, sorry. Yes. So the way that, let's see, it asked you to write the similarity statement, which is here. It asked you to find the scale factor is here. Because it said, are the pools similar? The reason I'm saying that is because that's the definition of similarity. Okay. Corresponding angles are congruent, corresponding sides are proportional. And so you aren't able to use like angle, angle, or side, angle, side. So if it's a quadrilateral or something that's not a triangle, you have to use the definition, and that's what that is. So on this, yes, if I'm wanting you to kind of like explain what's going on, you're going to have to tell me that that's the reason how you know that they're similar. So all the angles are right angles, so all the angles are congruent. And then you verify that the sides are proportional. Okay, you guys are so quiet. Jake and Jerron, without you here, it's just not even the same.
What did you say?
Huh? I don't know. I wasn't listening.
She said it's not the same without us there. Like answering.
I said both.
I see what she.
Look at you, Jake. Don't get too big-headed. Okay. I want you to go back to, this is the notes from yesterday. The angle, side, angle, side, lesson 7.3. We're going to go back and fill in some of the notes on some of the problems that we didn't get to on certain days, and make sure we're good with how to show if in this case triangles are similar. Okay, so ways of proving the triangle is similar. Peter, name one of the ways that we use to prove triangle similar. Side, angle, side. Kendall, name a way. Angle, angle. And then what's the last one? Side, 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 right. Okay, now we can of course use the definition, but these are the shortcuts where you don't have to check all the angle measures are pairwise congruent and all the sides are pairwise proportional. Okay, what, it says identify the similar triangles and then find each measure. What can we get from parallel? Why do they give you parallel in problems? What do you get from the fact that those segments are parallel? So look at, these are parallel. That's a transversal. What can you get from that, Lily? Tell me which angles you're looking at when you're saying corresponding. Okay, sometimes you will get corresponding angles. Do we have parallel lines? Yeah. So here we had parallel lines and these angles are corresponding, right? So those are congruent, and then same thing over here. We have congruent angles there. This one you don't have corresponding, but you do have some kind of angles like that. Where is there a pair of congruent angles? Peter? This one, are you saying B? Okay, are those congruent? Yes, but it's not because the lines are parallel. Why are those angles congruent? Those are vertical, right? You would call that EBD and CBA. Okay, that you'd have to use the three letters there. Okay, so vertical angles are congruent. You can certainly use those angles. And then what do you get from the parallel? I'm a little sad right now. Alternate interior. So which ones are I'm naming angles, Derbla? Okay, hold on. X is this length right here. Use the letters. C. Okay, angle C and E. Good. Those are what kind of angles again? Yes. If lines are parallel, then alternate interior angles are congruent. Now, you could have used the alternate interior angles also here and here. So you don't have to use the vertical ones at all, but remember you need at least two pairs of congruent angles. So why are the triangles similar then? Angle, angle. Okay, it says identify the similar triangles. That means give a similarity statement. Blair, can you tell me a similarity statement? Triangle. Is similar to. Good. How did you determine how to match them up? Okay, so you can see, because we already determined that we have the alternate interiors there, you can tell that those guys have to go together, and you can tell that the vertical angles have to go together, right? So she had to have B and B matched up, and then you get the other angles match up the same. Now, we know the triangles are similar by angle, angle, and now we need to find the value of X. All right, so we have some numbers here. We have 30, 23, and X in the triangle on the left side. Okay, so we have 30, 23, and X in the triangle over here. And then we have 38.6 and 60 in another triangle. So let's figure out what sides match up. So in the triangle over here, the 30, what does it match with in the other triangle? 60. Okay, and then I know in my proportion, I'm going to have to be finding X, so I want to figure out what matches with X. So does X match with 38.6, or does X match with this side over here? So 38.6, which number does it go with? Does 38.6 go with the 23 or with the X? Okay, so let's figure out based on the angles. So 38.6 is between the blue angle there and the pink angle, right? What side in the other triangle is between the blue angle and the pink angle? Which one matches with 38.6? X, yes. So that means that the 23 they gave you there really does not matter. It's just there to confuse you. Okay, don't even worry about the 23, it's not necessary. Okay, I need a proportion to solve for X. Austin, can you give me a proportion to solve for X?
38.6
Okay. So if we do 30 over X, that's the circle over the square, we'll need to do 60 over 38.6. Okay, I would like a different way of setting up the proportion. So somebody give me a different proportion. X over equals 30 over 60. Okay, or any equivalent proportion of that would work. I kind of like this one because what is the scale factor between the two triangles? It's 1 to 2, right? So if you kind of notice that the ratio there is 1 to 2, here you can just reduce that down to 1/2. And then really you're just trying to, figure out half of 38.6. You can, of course, cross multiply and do 2x equals 38.6. But if you just think, okay, I'm trying to make this a 1/2 ratio, that number on the top needs to be 19.3 for that to be a 1 to 2 ratio. Okay, but you have to be careful about how you match up the sides. So they didn't give you a similarity statement here for you to figure it out. You have to use what you know about how the angles match. Okay, in the next one, the triangles. Do you see the triangles that they're referring to? So what is the name of one of the triangles? Braden, name one of the triangles. And say it again. NPF, okay. All right, so we have that triangle. I'm going to copy that down here. This is NPF. Okay, and then where's the other triangle? Sarah? RQF. Oops. Okay, I'm going to copy down the numbers that we've got there just so we kind of have everything on the picture. So in the little triangle, we have 30 and we have 32. In the big triangle, this side is 22. What is side FN equal to? That's 40, right? And then on this side of the triangle, oh my goodness. Kara, tell me what that side of the triangle should be. Okay, Kara, what's the length of side FP? 32 plus X. Okay, so make sure we get a plus in there and don't make that 32X. So 32 plus X. Okay, now let's look back at the original picture here because we haven't actually determined why the triangles are similar. Jake, can you tell me something we could mark from in the triangles?
Angle FRQ is congruent to angle FNP.
Why?
Isn't it like corresponding angles?
Yeah, so this one, we have parallel lines again. The purpose of parallel is to give you angle measures. Okay, every time that they give you parallel, the purpose is to have like corresponding angles or ultra interior angles. So those two are congruent because if lines are parallel, then corresponding angles are congruent. Okay, where's there another pair of congruent angles? This can be anybody, it doesn't have to be Jake. Where? Okay, so if you say P, I know exactly which triangle you're talking, or which angle you're talking about. You have to, I'm sorry. This one? Yeah. So just be careful if you're going to name an angle. Again, that when there's more than one angle with the same vertex. Okay, so those are the same reason, right? Both of those are pairs of corresponding angles. So the triangles are similar by angle. FRQ is similar to triangle FNP by angle. All right, we're supposed to solve for X. So I need a proportion. I'm going to scoot this over a little bit here. Rylan, give me a proportion. Okay. (32 plus X over 32). Okay, now notice we didn't have to use the 22 because we don't even know what the corresponding side there is equal to. So the 22 isn't really very helpful. Now, before you cross multiply, there might be something you'd want to do. What might be helpful? Yeah, go ahead and divide out the 10 there and just make it 4/3. Okay, so when we cross multiply, we're going to have, I'm going to write this like this first, just so we don't have any mistakes on the distributing and everything. 96 plus 3x is equal to, it's 128, right? 128. 3x would be equal to 32. X is 32 over 2. Sorry, 32 over 3. So should I leave it like that, or do I need to simplify or something? Yeah, you can leave it that way. There is nothing wrong with having an answer like that, as long as, you know, I don't mind it being improper as long as it's reduced. If you want to make a mixed number, you can. No reason to do that, just waste time. If you're going to put it into a decimal form, it's going to have to be a repeating decimal. Do not round. That's one of the biggest things that happens on this quiz/test material, is that students start taking every answer like that and putting them into decimals. Don't waste your time. I mean, it would be a repeating decimal, but there's really no reason to. If you do 32 divided by 3, you're going to see that that means it's 0.6 repeating. Okay, if you round that off to 0.6 or 0.7, it's going to be a deduction. Okay, how about this one? So let's add some things onto the picture that we know, but it is not shown on the picture yet. What can I mark on the picture? Lengths could I mark on the picture that isn't shown, but we know. Awesome. You wanted to tell me, no? Durable. Okay, so we've got congruent marks there, right? So we know that's 13. What else do we know? GH is 26. Okay, how about these segment lengths? How long is GU? 39. Okay, same thing up here. Now, we don't know, we know that this is 20. We don't know what that side length is. We're not going to be able to do side, side, side because we don't have all the side lengths. Okay. We also are not going to be able to do angle because we don't have parallel this time. Be careful, because if those were parallel, we could be like, oh yeah, those angles are congruent. We don't have parallel this time. So if we can't use angle and we can't use side, we're going to be looking for using side, angle, side. Is there anything that we can do to use side, angle, side, Peter? Uh-huh. Okay, so we're trying to compare the triangles. So if I do the same thing that I did before, I'm gonna go ahead and grab this and move it over here, and that's GHW. Okay, and then I'm gonna do this and move it over here. You're looking at a triangle and a trapezoid-ish looking thing. You're looking at a triangle and a quadrilateral if you talk about HW being shared, right? This is GIU. Segment HW is in the little triangle, but it's not a side of the big triangle. It's a side of the quadrilateral, but that's not what we're trying to do. We're trying to compare the triangles. Okay, so in the little triangle, we know 26, 26, 20. And in the big triangle, we know 39, 39, and then that's the side we don't know. Okay, how can you use side, angle, side? Sarah? What's the reason that I can mark that? So why is that the same? Yeah, there was a property that we used. You guys remember what that was when you had like something congruent to itself? It's okay, we haven't done it for a while. That was reflexive. Whenever you have a shared side or a shared angle, you can always use that as being congruent. So how do we know that the triangles are similar? Well, what's this ratio? What's the ratio here? 1 to 1. And what's the ratio here? 1 to 1, right? So since we have angle G is congruent to angle G, and 26 to 39 equals 26 to 39, or 26 to 26 and 39, 39. And then triangle GHW would be similar to triangle GIU by side, angle, side. Okay, remember that for side, angle, side, you have to have a pair of congruent angles, and then the sides that form those angles have to be proportional. Okay, so to find the measure of the length of X, so X is here. What side corresponds to X? Another triangle. What side corresponds to X in another triangle? Izzy, what side in another triangle corresponds to X? So X is here. 20, right? 20 and X go together. They're both kind of like, I'm thinking of this triangle as like sideways. So this is like the bottom. That's how I'm thinking of it. So the bottoms are matching up. And then it doesn't really matter which side you use, because you got 26 on both of them. You can use the 26 there and the 39 there. Now, again, when you're doing this on paper, you can do like X goes with 20 and 39 goes with 26, and you're trying to match things up. Okay, or if you need to do 26, you make a little cloud or make a triangle, just mark them so you can keep track of what sides go together. Okay, to find X, I need a proportion. Diamond, give me a proportion. Equals. You'll be able to simplify this, but I need a proportion before we worry about simplifying. 26 is to 39 as Okay, I want you, we gotta solve for x. Yeah, as 20 is x. Now, I would definitely go ahead and simplify. We can take a 13 out of both of those. So if we divide out a 13, we'll have 2 to 3. Now, we can, of course, cross multiply to solve that. But again, I would encourage you to kind of use your number sense here and think, if we're turning 2 into 20, we'd multiply by 10. So that means the bottom would have to be multiplied by 10 as well. And x is what? X is 30. Okay. You can also look at this and say 20 over what is supposed to reduce down to 2/3, right? Or of course you can cross multiply. But when the numbers are nice and simple like that, it's a good idea to kind of reason through it, thinking, okay, I would just have to multiply by 10. What is the scale factor of the two triangles? Let's do the small and the big. What's the scale factor of the small one to the big one? If you say 3 to 2, that's definitely big to small. 2 to 3. So why is it not 2 to 1? Why is the scale factor not 26 over 13 or 2 to 1? Because what? Yeah, you need to make sure you're comparing triangle side lengths, right? This is not a side of a triangle. So those little segments are in a 2 to 1 ratio, but you want to make sure you're thinking of it like that. So if it's not pulled apart, it tends to be a little trickier. If you need to redraw them pulled apart, then do that, if that helps you see what's going on. But the ratio would either be 26 to 39 or 39 to 26, depending on which way you're doing it. 26 to 39, which is 2 to 3. Okay, we're not using a 2 to 1. Because if you tried to say it was 2 to 1, that would mean that this length should be, I don't know, 10 or 40, whichever you would be, whichever way you think it'd be going, which it's not. Okay, that length was 30. All right, and then here's one. The heights of two vertical posts are 2 meters and 0.45 meters. When the shorter post casts a shadow that is 0.85 meters long, what's the length of the longer post shadow to the nearest hundredth? We have two vertical posts. This will get thicker. We got two vertical posts. One is 2 meters and one is 0.45 meters. Okay, the shorter post casts a shadow. I'm going to draw a triangle here. So like this. Draw a triangle. This will be a right triangle, right? And this little triangle here. Now, when I label, it says the shorter post casts a shadow that's 0.85 meters long. When I label the shadow, which side of the triangle is the shadow? This one is the shadow? Oops. This one's the shadow? This one's the shadow? Blair, have you ever stood outside and seen your shadow? No? Wait, what? Have you ever stood outside and seen your shadow? Okay, where do you see the shadow? On the ground, right? It's a projection of your height onto the ground. So make sure that when you're talking about shadows, the shadows are always on the ground. So this would be a 0.85 meters. A shadow does not like hover off your head in the air, right? You don't see someone's shadow like hanging in the air. It's always on the ground. Okay, so that was 0.85. And then the length of the longer post shadow is what we're looking for, and pay attention to the rounding. Okay, so I need a proportion. Jerron, can you give me a proportion?
You would have 2 over 45.
Okay.
And then you would have x over 85.
Okay, tell me why it's okay to make it 45 and 85.
What do you mean?
Because it was supposed to be 0.45 and 0.85. Did you just ignore the decimal points?
Oh, yeah, that's what yeah, I didn't mean the point. I meant to put the points.
Okay.
Like 0.45 and 0.85.
I thought you were doing some fancy math.
Oh, no, I just forgot.
It would actually be okay to do that. We'll talk about why in a minute.
Oh.
Sadie, can you give me a different way to set up the proportion? Sadie, 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 Sadie. Hello, Sadie. Okay, I haven't talked to Peter. Uh-huh. The problem said 0.85. Yeah, I didn't make that up. Okay, so if we do 2 to 0.45 and x to 0.85, that'd be fine. What's a different way to set it up? Is Lily. Okay, so 0.45 over 0.85. You know how Geron had said 45 over 85 at first? That's okay, because notice that really what that is multiplying this by 100 and that one by 100. And it would, like, you multiply the top and the bottom by 100, it would just get rid of the decimal. So it actually would be okay to call it 45 and 85. I would be careful with doing that in general, but that would be okay. All right, so if you don't want to have to work with the decimals, you could go ahead and do that, multiply the top and the bottom and get rid of the decimals. But we're using a calculator, it's not any problem to do that. 2 times 0.85 is 1.7, and then 0.45x divided by 0.45. Ooh, 3.7 repeating. Now I think it asks us to round to the nearest 100. Okay, so what does that round to the nearest 100? 3.78. What's the label? Meters. Okay, so lots of little places to make mistakes. Watch out for the rounding. Okay, watch out for like what you're supposed to round to. Watch out about not rounding when you're not supposed to round. So again, on one like that, don't round unless it tells you to round. So, you know, you're going to miss little points here and there for rounding. That's going to be sad. So try not to miss points for rounding. What do you mean? All right, let's go back and look at a reminder here about quadratic formula. Let's do a quadratic formula problem. You guys want to do 14? I went back to, this is 7-1 day 2 on quadratics. It was from like 3 class periods ago. So last week. You want to do 14 or 15? Any preference? Gerbil, do you want to do 14 or 15? What do you think? 14. Okay. Sarah, tell me the first thing you would do. So we're solving quadratics here, and it says to solve with the quadratic formula. What's the first thing? Yeah, you need to get the A, B, C. So what do you have to do before you pick off A, B, and C? Right. So remember, for quadratic formula or for factoring, you always get it equal to 0 first. Okay, so let's go ahead and pull that over. It'll be 4p squared, and then what? Plus 4p minus 9. Okay, so our A is 4, our B is 4. What's C? Negative 9. Make sure you take the sign along with it. Okay, can you rattle off the quadratic formula? Negative b plus or minus square root b squared. It's minus 4ac all divided by 2a. Guys, you got to know the formula. My honors kids, some of them don't know the formula, and so they were missing points on like doing hard stuff and then not able to do this kind of problem because they didn't know the formula. All right, so we plug that in. It'll be negative 4 plus or minus the square root of 4 squared minus 4 times negative 9, all over 2 times 4. Now, A, let's see, here's B and B. So this 4 and that 4 are B. I'm just trying to, because the same number is being used twice. The 4 here and the 4 here are A. I wouldn't normally do an example where you've got the same number repeated. It makes it hard to follow. Okay. Michael, can you tell me underneath the radical what we should do? Okay, so we want to do 4 squared and it's separate, right? Yeah. So 16. And then we're going to go ahead and multiply all that together. What is this sign going to be in here? Is it a plus or a minus? It'll be a plus. So you have a double negative, right? We've got minus and then times with a negative there. So because you have these two negative signs, that's going to mean that you have a plus here. Okay, 4 times 9, 144. Notice that if you had done something wrong here and you got a minus, what does that tell you? There's something wrong because you should not get a negative underneath the radical sign in geometry. In algebra 2, you'll be able to get a negative in there and know what to do with it. Right now, we're working in real numbers and you should not be getting negatives underneath the radical sign. Okay, let's see. What is 16 plus 144? That is, what, 160? All right. Okay, how can we break down 160? Square root of 160. 4 and what? It's 4 root 10 because it's what? Break it down in square roots. 16 and 10. Okay, so 16 is a perfect square and it's the largest one that goes into 160. 4 goes into it as well, but it's not the biggest one. You want to make sure you get the biggest one if you do it that way. So negative 4 plus or minus 4 root 10 all divided by 8. Now we still got to do one more thing. What can we do there? Simplify. What's it going to be when we simplify? So what are we allowed to simplify? What can we take out of 8? 4. So should I take it out of just those or do I take a number out of there too? Yes. The common mistake is that you guys, some of you will divide by 2 on everything and you'll change that radical. The square root of 10, remember that 10 is protected by the radical. So we can go ahead and divide out a 4 from everything. So divide that by 4, divide that by 4, and divide that by 4. But we're not going to do anything with the radical. We're going to leave the radical alone. So what will that be when you divide out the 4? What will your final answer look like? What's that going to be when you divide out the 4? Ryan, tell me what your answer is. What was the number in front of the radical? -1 plus or minus what? Okay. Divided by what? 2. Okay. Are any of those ones unnecessary? Okay, so it's perfectly fine. The way you wrote that, not a problem. But if you don't want to write that 1 there, you don't need it. You have to have this -1 there. So it's good you did not accidentally lose that. The 1 here is optional. So -1 in the front has to be there. Okay, but make sure you don't do anything with that 10. It needs to stay as it was. Okay. The homework is posted as number, I'm not sure what. Look here. 22 maybe? Okay. So the test is on Thursday. We're making this a test because we didn't want the chapter 6 test to be like such a huge chunk of your grade since there was only 1 test. That means that this is a big chunk of your grade, okay? So if you want to know how to raise your grade, you look at your chapter 6 test grade, and anything above that raises you, anything below that will drop you. Let's see. Let me go play the quadratic formula sign for you. Yes. Did you sign up for the same time? Kendall, did you sign up for the same time?
Yeah, I did.
Okay. Did you?
No, I didn't.
I was gonna say, I don't remember getting.
I have like 3 tests.
Okay. This one isn't until Thursday, but yeah, make sure you do that. Let's see. Let's do this one.
X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a.